All right, now I would like to do a quick rundown of integrated rate laws, if I can do it quick, I don't know. Um, so with rate laws, the purpose was to look at how concentration affected the initial rate. So your data was concentration versus initial rate. You would have those in the different columns. For the integrated rate law, we're looking at the relationship between time and concentration, how the concentration of a reactant changes over the course of the reaction. And so, once again, um, the equation changes depending on what order you have, and they look even more different than the rate law because the only thing that was changing in the rate law was the power. Now you're changing the whole look of the equation. So zero order, what you have here is the concentration of A at time t is equal to the negative rate constant times time plus the concentration of A at time 0. For first order, it's the natural log of A at the natural log of the concentration of A at time t is equal to the negative rate constant times time plus the natural log of the concentration of A that's supposed to be at time 0. My fault. Then on second order, it's the inverse concentration of A at time t is equal to the rate constant, it's not negative this time, times time plus the inverse of the initial concentration of A. Now what I want you to notice is that in each of these situations, it takes a y equals mx plus b form. So in other words, if you take the data, which your data is going to look like this, it's going to be time versus concentration. If you take your data and you graph time versus concentration, notice in zero order you have time and just regular concentration. If that makes a straight line using that equation, it's going to be zero order. For first order, if you take the natural log of the concentration and graph that versus time and it makes a straight line, well, it will make a straight line for first order, that's what I mean to say. And then for second order, it'll make a straight line when you graph the inverse concentration versus time. So you can actually figure out what order it is just by graphing the data in different forms. So, what we need to talk about is how to actually graph it. And to do this, you're going to need a graphing calculator. And you'll go to Stat, Edit, and that's going to take you into your little table that looks like this. What you'll do, since you're always going to be given data that looks something like that, put time in L1, and then put in your concentration values in L2. That, depending on how much data that is, that could take you a little bit of time, but the calculating that can be done for you is going to save you time in the end. L3, what I would like you to do is put in the natural log of the concentration, and how you do that is highlight L3 so that you don't have to put in the natural log of the previous point each time. Highlight L3 and then just put natural log second 2, which will make it look like natural log of L2, and then hit enter, and it will fill in all the data for you. And then the same thing goes in the fourth column over here. What you're going to do is the inverse concentration, so you do 1 divided by the concentration of A, but highlight L4, and then when you're up top, put in 1 divided by L2, and hit enter, and it'll fill in all the data. So in each case, what we're going to do is we're going to do a linear regression. To get that, you'll go to Stat Calculate, okay, Stat Calc, and then find the number 4, which is linreg, and it's ax plus b is what it says. So find that, and when you found that, what you have to decide is what data parts to put in as your x and y. Well, looking at the zero order equation and using the y equals mx plus p form, in each case, actually, not just the zero order, you can tell that time is always t, okay? That always goes in, time is always t. Time is always x. It always falls in that area. So the L1 column is always going to be x. What you are changing is actually what the y is. So if you'll notice in the 0 order, y is just the concentration, okay? That's for 0 order. In first order, y is the natural log of the concentration. So this is y for first order. And then for second order, y is the inverse concentration, okay? So what you want to do is a linear regression for each situation. So you're going to do a linear regression using these two, where the x value is L1 and the y value is L2, okay? And that will be for 0 order. Then you can do the L1 is x and the L3 is y, and that would give you the first order situation. And then you can do, hey, yeah.